In this module, we will study the modern theory of cost in both the short run and the long run. The modern theory, which is to be distinguished from the traditional theory of costs, suggests the existence of built-in reserve capacity which imparts flexibility and enables the plant to produce larger output without adding to the costs. Built-in reserve capacity is planned by firms. Modern theory of costs does not agree with the traditional theory of costs, which says that cost curves are U-shaped. The short-run cost curve in modern theory has a saucer-like shape, and the long-run average cost curve is either L-shaped or shaped like an inverse J. According to the modern theory of costs, the firm can produce a range of output and not a single level of output as under the usual traditional theory of costs. Firms build industrial plants with some flexibility in their productive capacity so that instead of a single output level, there is a whole range of output that can be produced optimally at low cost. This reserve capacity, that is capacity which has a certain reserve ability and which is built in, provides maximum flexibility in the production process. This planned reserve capacity is what explains the saucer-shaped short-run average variable cost, or AVC. The modern theory of costs stresses on the role of the economies of scale, which enable the firm to continue production at the lowest point of average cost for a considerable period of time, not just a point of time. The firm checks this economies of scale by planning in advance and enjoys the gains of production in comparison to the traditional theory, where the firm finds that the average cost is rising after the firm reaches the optimal level of output. Developments in managerial economics explains the L-shaped and inverse J-shaped long-run average cost curves.
After studying this module, you will be able to know the modern theory of costs, learn the difference between the traditional and modern theory of costs, identify reserve capacity, evaluate economies and diseconomies of scope, analyze different types of shapes of long-run cost curves. The modern theory suggests the existence of built-in reserve capacity, which imparts flexibility and enables the plant to produce larger output without adding to the costs. Built-in reserve capacity are planned by firms. Modern theory of costs does not agree with the U shape of the cost curves. The short-run cost curve has a saucer-type shape, whereas the long-run average cost curve is either L-shaped or inverse J-shaped. According to the modern theory of costs, the firm can produce a range of output and not a single level of output as under the traditional theory of cost.
The short-run average costs consist of the average fixed costs and average variable costs. Because of the U-shaped average variable curve under the traditional theory, the plant is designed to optimally produce a single level of output at the minimum point of the AVC curve. In case there is any departure from the optimizing output, there arises an excess capacity or unplanned capacity. If the firm produces a lower level of output, OX1 say, then the costs would be high compared to OX2 level of output. The short-run average variable costs, SAVC, thus has a saucer-type shape where there is a flat stretch corresponding to the reserve capacity which the plant builds to provide flexibility in the firm's production process.
Let us now first discuss the shape of average variable cost curve under traditional theory of cost. The short-run average costs consist of the average fixed costs and average variable costs. Because of the U-shaped AVC curve under the traditional theory, the plant is designed to optimally produce a single level of output at the minimum point of AVC curve. In case there is any departure from the optimizing output, there arises an excess capacity or unplanned capacity.
Average variable cost. The average variable cost is equal to the total variable cost divided by the total output. AVC equals TVC divided by Q, which makes it P into V together divided by Q, where P is the price per unit of output and V is the quantity of the variable input. The average variable cost curve is not U-shaped as under the traditional theory, but trough-shaped or saucer-shaped under the modern theory of cost due to the reserve capacity maintained by the firm. Marginal cost. Marginal cost is the change in total cost that arises when the quantity produced has an increment by a unit. That is, it is the cost of producing one more unit of a good. In general terms, the marginal cost at each level of production includes any additional costs required to produce the next unit. The marginal curve intersects the average curve, that is, the marginal cost curve intersects the short-run average variable cost curve at its minimum point. Since the SAVC reaches its minimum point not at a single point but over the whole flat stretch, therefore, the short-run marginal cost curve SMC coincides with the SAVC over the entire range of output corresponding to the flat stretch of the SAVC curve. So, there is an entire range of output along which the two curves are coinciding. The graphics will show us both these concepts.
Let us now first understand different cost curves under this theory. Average cost curve is the sum of AFC and AVC. Under conditions of reserve capacity, the curve is downward sloping, falling continuously as output expands. The average variable cost is equal to the total variable cost divided by the total output. It is not U-shaped as under the traditional theory, but saucer-shaped due to the reserve capacity maintained by the firm. Marginal cost, which is the addition to the total cost as a result of a unit increase in the output. The MC curve intersects the SAVC curve at its minimum point. Since the SAVC curve reaches its minimum point not at a single point but over the whole flat stretch, therefore, the short-run marginal cost curve coincides with the SAVC over the entire range of output corresponding to the flat stretch of the SAVC. Let us now understand the relationship and shapes of different cost curves under modern theory of cost. The following proportions of the SAVC curve show the reduction in costs due to better utilization of the fixed factors and the consequent rise in productivity of the variable factors. The rising portion of the SAVC curve depicts the rise in costs on account of diminishing returns from the variable factor and also overutilization of the fixed factors. The SAVC curve has a flat stretch over a range of output wherein the SAVC is equal to the short-run marginal cost, both being constant per unit of output. The short-run average cost curve continues to fall even over the range of output x1 and x2 corresponding to the flat stretch of the SAVC curve wherein SAVC is assumed to be constant. As average cost consists of average fixed cost and average variable cost, and average fixed cost continues to fall as the level of output increases. Even after the planned reserve capacity is exhausted, the short-run average cost curve continues to decline despite rise in SAVC because AFC continues to fall throughout. Eventually, the rise in short-run average cost becomes greater than the fall in average fixed cost and the short-run average cost starts to rise. The SAC curve is intersected at its lowest point by the short-run marginal cost curve, as in case of the traditional theory of costs. Beyond OX3 level of output, the SAVC curve asymptotically approaches the short-run average cost SAC, since the gap between the two curves gradually diminishes on account of falling AFC, but the two can never coincide because AFC cannot be zero.
Economies of scale are the cost advantages that a business can exploit by expanding their scale of production in the long run, making things cheaper because they're bigger. The effect is to reduce the long run average unit costs of production over a range of output. These lower costs are an improvement in productive efficiency and can feed through to consumers in the form of lower market prices. But they can also give business a competitive advantage in the market. They lead to lower prices but also higher profits. Consumers and producers thus can both benefit. The scale or size of production is usually measured by the number of units produced over a period of time. If the scale of production increases, average unit costs over most production ranges are likely to fall because the company will benefit from economies of scale. Beyond a point, a company will start to find that inefficiencies push average costs up and diseconomies of scale set in. Financial economies are thus cost savings that arise from the way in which large firms raise money. Marketing economies is cost savings resulting from the way in which the firms sell their products. Technical economies are cost savings caused by the methods of production used. Risk-bearing economies are cost savings that result from the way in which a firm tries to reduce the risk of a fall in demand for some of their products. Diseconomies of scale, on the other hand, can be classified as management diseconomies resulting from coordination problems amongst various departments within a firm. Labor diseconomies resulting from too much specialization, making workers very bored with their repetitive and often very boring and monotonous jobs.
Economies and diseconomies of scale explain why under the traditional theory of costs, the LAC curve is U-shaped, and under modern theory, the LAC is L-shaped. Alfred Marshall classified economies of scale into internal economies and external economies. Internal economies are internal to a firm and are not shared by its competitors in the industry, while external economies are those benefits of large-scale production which accrue from outside due to the growth of the whole industry.
A significant recent development in cost theory is that the long-run average cost curve is L-shaped rather than U-shaped. The L shape of the long-run average cost curve implies that in the beginning, when output is expanded through increase in plant size and associated variable factors, cost per unit falls rapidly due to economies of scale. Even after a sufficiently large scale of output, the long-run average cost does not rise. It may either remain constant or it may go on falling slightly. At a very large scale of production, the managerial cost per unit of output may rise, but the technical or production economies more than offset the managerial diseconomies, so that the total long-run average cost does not rise or may even fall continuously, though at a very small rate. Thus, the empirical evidence gathered by economists in recent years does not support the U-shaped long-run average cost curve which traditional theory of costs has upheld so far. Empirical evidence indicates that initially the long run average cost rapidly falls, but after a point it remains flat throughout, or at its right hand end it may even slope gently downwards. Joel Dean in his studies has found out that long run average cost curve is U-shaped. J. Johnston has found strong evidence again for L-shaped long run average cost curves. Besides, using data belonging to Indian industries, Vinod Gupta has found out that out of 29 manufacturing industries in India, 18 of them had long run cost curves which are of the L shape. The difference between L-shaped LSE and U-shaped LSE is that there is no rising portion in the former. Indeed, as we have said earlier, empirical evidence shows that LSE may even slope gently downwards towards its right hand end. Now, let us understand this with the help of graphics.
The shape of the long-run cost curve is dependent on the returns to scale. The traditional theory assumes a U-shaped long-run cost curve under the presumption that after the optimal level of output, the diseconomies of scale overtake the economies of scale. The modern theory contends that the long-run average costs essentially comprise production and managerial costs, of which the average production costs continue to fall even at large scales, while the managerial costs per unit of output may rise only gradually and at large scales of output. The long-run average cost curve is L-shaped or inverse J-shaped under the modern theory of cost. Let us now understand the L shape of LAC curve. In figure, we find that as the average cost of production falls continuously with the increase in the level of output, the LAC curve assumes an inverse J shape, which signifies that there are no diseconomies of scale even at very large scales of output. If the average cost of production continues to fall only till a certain optimal level OX1 and beyond that it becomes constant, then the LAC curve is roughly L-shaped, and this signifies that the economies and diseconomies of production balance out each other beyond the optimal level of output OX1. Let us now move to J-shaped LAC curve. The LRMC will lie below the LAC curve at all output levels, since the average costs of production can fall continuously if and only if the LRMC pulls them downwards by remaining below it. The LRMC lies below the LAC curve until the minimum optimal scale is reached and coincides with the LAC beyond that level of output. According to the modern theory of costs, the long-run average costs essentially comprised of production and managerial costs, where the fall in production costs more than offsets the rise in managerial costs. Thus, the LAC curve either falls continuously or remains constant at very large scales of output.
You must be wondering how to explain this apparent contradiction between theory and empirical evidence. Two explanations can be given. One is technological progress. One reason why modern empirical studies do not find U-shaped long-run average cost curves is that whereas economic theory assumes that technology remains unchanged or there is no technological progress, in the real world technological progress takes place all the time. As a result of this ongoing technological progress, long-run average cost curve shifts downwards over time. The empirical investigations based on time series data would not thus find rising average costs in view of the existence of this technological progress. In the case of unchanged technology as assumed in traditional cost theory, the long-run average cost curve is U-shaped, empirical studies conducted on the basis of data belonging to different points of time between which technological progress has taken place, or inter-cross section studies where both small and large firms using different technologies are included, would find average cost falling. In view of the technological improvements, we cannot therefore find average cost rising in empirical cost function studies. The fact that technology change does not in itself contradict our convention that if only because it is harder to manage a larger firm than a smaller one, long-run average cost curves will be U-shaped in a given state of technology. What the empirical evidence does suggest is that technological progress may often be rapid enough to reduce unit cost even in a situation where, given technology, the problem of managing a bigger firm would increase unit costs. What about the second explanation? This is through the learning curve effect, which is another factor which causes long-run average cost curve to slope downwards throughout. It is common knowledge that a person, while doing some productive work, learns how to do it better. The greater the amount of work he has done since the time he started doing a particular activity, the greater the experience he attains, and the greater the experience he learns to do the job better. This tends to reduce per unit cost. A firm learns to produce a commodity more efficiently as the aggregate amount of its output produced by it increases over time. A good deal of empirical evidence is available which goes to prove that the firm's cost of production depends not only on the amount of output of a commodity it produces each month or year, but also on the aggregate amount of that commodity. Aggregate amount produced since the time it started its production. This is because the aggregate output by a firm to date determines the degree of learning it has acquired and the efficiency that it has gained through it. Therefore, we can draw a learning curve which relates the average cost of production of a commodity to the aggregate amount of output produced so far of that commodity. This learning curve slopes downwards, indicating thereby that as the aggregate amount of output produced of a commodity by a firm increases over time, cost per unit may go on declining because a firm learns to produce a commodity more efficiently and therefore at lower cost of unit as it proceeds. It should be noted that with the increase in aggregate production of a commodity over time, learning gained by the firm is not only in respect of improving the efficiency in physical operations, but in also the production of improving the organization, better job performance and better way of arranging the workings of the unit. Thus, besides the factor of technological progress, learning provides another reason why long-run average cost curves are L-shaped rather than U-shaped as we have been taught traditionally. According to empirical evidence, long-run average cost after the initial rapid fall either remains constant or declines throughout instead of rising. That it certainly does not. The long-run average cost, if it is U-shaped, this is what we expect. Professor G.A. Smith, who has examined empirical evidence, has concluded that with a very large size of firm, Labor costs, assembly costs, distributional costs are very difficult to calculate, add up and secure, which is why plants with increasing average cost are not set up with actual practice, but immediately we find that it is better found abroad, the cost of situation in them. Therefore, empirical evidence cannot assess the cost situation in them. According to Professor Smith, empirical evidence does not refute the U-shaped nature of long-run average cost curve. Walters, after examining the empirical studies by Dean and Johnson, reached the conclusion that there is no large body of data which convincingly contradicts the hypothesis of a U-shaped long-run average cost curve and the fruitful results which depend on it.
In this module, we have learned the difference between modern and traditional theory of cost. The modern theory of cost believes in L-shaped cost curves and the existence of built-in flexibility and the reserve capacity, which enables the firm to produce different levels of output at the same cost. The economies and diseconomies of scale explain the L-shape and inverse J-shape of long-run cost curves.
To summarize, modern theory of costs does not agree with the U-shape of the cost curve which the traditional theory advocates. The short-run cost curve in the modern theory has a saucer-type shape, whereas the long-run average cost curve is either L-shaped or inverse J-shaped. The modern theory suggests the existence of built-in reserve capacity, which gives flexibility and enables the plant to produce larger output without adding to costs. Built-in reserve capacity are planned capacity, planned by the firms. Because of the U-shaped AVC curve under the traditional theory, the plant is designed to optimally produce a single level of output at the minimum point of the AVC curve. In case there is any departure from the optimizing output, there arises excess capacity or unplanned capacity. The short-run average variable costs SAVC has a saucer-type shape where there is a flat stretch corresponding to the reserve capacity or the planned capacity which the plant builds to provide flexibility in the firm's production process. Average fixed cost under conditions of reserve capacity is downward sloping, falling continuously as output expands. Average cost curve is the sum of AFC and AVC. Initially, both are falling, causing the AC to fall. AFC continues to fall, but AVC remains constant, causing AC to decline. After the reserve capacity is fully utilized, AC starts rising. The MC curve intersects the SAVC curve at its minimum point. Since the SAVC reaches its minimum point not at a single point as in the traditional theory, but over the whole flat stretch, therefore the short-run marginal cost curve SMC coincides with the SAVC over the entire range of output corresponding to the flat stretch of the SAVC curve. Over the flat stretch pertaining to the reserve capacity, the short-run marginal cost curve coincides with the SAVC curve. The economies and diseconomies of scale explain why under the traditional theory of costs, the LAC curve is U-shaped, while under the modern theory it is L-shaped. Internal economies are internal to a firm and are not shared by its competitors in the industry, while external economies are those benefits of large-scale production which accrue from outside due to the growth of the whole industry. Economies of scale are usually measured in terms of cost output elasticity, which is defined as the percentage change in the cost of production resulting from a percentage change in output. EC is equal to delta C by C divided by delta Q by Q. If EC equals 1, then the firm's economies of scale are equal to the diseconomies of scale. If EC is less than 1, firm enjoys economies of scale. Its proportion of cost changes is less than the proportion of output changes. If EC is greater than 1, we find diseconomies of scale are exceeding the economies of scale.